Sorry, I don't hear anything. Is it okay?
It's okay. Now we can start, Eric, okay?
Okay.
So please join me in welcoming Dr. Eric Monacelli, who is full professor at University of Versailles, Saint-Quentin en Yveines in France. He also chairs the robotic team
I don't hear anything. Is it okay?
It's okay. Now we can start, Eric, okay?
Okay.
Everything is delayed.
Try it again.
Eric? Bonjour. Eric.
Yeah. Yeah. There is a double.
Est-ce qu'on est synchronisé, Eric? Are we synchronized?
Now we can start, Eric.
Eric?
Ouais.
Bonjour.
Moi, je t'entends.
Est-ce qu'on est... Okay. Dr. Eric Monacelli is full professor at University of Versailles, Saint-Quentin-en-Yvelines in France. He also chairs the robotic team at the Versailles Engineering Systems Laboratory called LISV, and he is also the president of non-for-profit French National Cluster for Mobility and Handicap, CRAM. He is passionate about mobility aids, assistive technology, robotics, and embedded systems. So Rick, you can start. You could have maybe around 45 minutes, and then we'll have room for questions. Cluster for Mobility and Handicap, CRAM. He is passionate about mobility aids, assistive technology, robotics, and embedded systems. So Rick, you can start. You could have maybe around 45 minutes, and then we'll have room for questions. Cluster for Mobility and Handicap, CRAM. He is passionate about mobility aids, assistive technology, robotics, and embedded systems. So Rick, you can start. You could have maybe around 45 minutes.
Amine, j'entends plusieurs fois ta phrase.
Is it now okay, Eric?
I heard multi times your talk.
Eric, you can start.
Is it
now okay, Eric?
Okay. So sorry for this late. So thank you for inviting me. So my talk will be about our lab and the activity around assistive technology, and I will focus on the way we couple.
Eric, you can start.
The way we couple assessment and adaptation for mobility assistance. So, do you hear me now? I just cut something, but I'm not sure you hear me.
Eric?
Cut something, but I'm not sure you hear me.
Eric, can you talk a little bit more? Sorry about this technical issue.
Eric? Yes, I hear, but I hear you more than once.
Actually, we are delayed.
Eric, can you talk a little bit? Est-ce que tu m'entends?
Oui, je t'entends.
Parce que je t'entends 3 fois, en fait. Plusieurs fois.
Désolé pour ce problème technique, Eric. On est en train de le régler tout de suite.
Non, c'est juste que... Est-ce que tu m'entends plusieurs fois, toi aussi?
Non.
Est-ce que tu m'entends?
Oui, je t'entends.
Parce que je t'entends 3 fois. Plusieurs fois.
Désolé pour ce problème technique, Eric. On est en train de le régler tout de suite.
Non, c'est juste... Est-ce que tu m'entends?
Thanks for your patience.
Est-ce que là, ça va mieux?
On va faire un test dans quelques secondes. Could we start? The Mio? Can we start? Okay. Yeah. Si tu pouvais attendre encore un tout petit peu, Rick, s'il te plaît, on est en train de résoudre un problème technique.
Ça a l'air j'ai coupé des choses chez moi, ça a l'air de mieux marcher.
Est-ce qu'on est synchronisé maintenant? Are we
J'ai
synced?
l'impression, I think we are synchro now.
We are synced. Can you answer now so that I evaluate if we are synced? Oh, are you watching the live stream here by chance?
Yeah, but
yes?
I don't have the camera, the display of your...
Oh, Eric, you don't have to watch the live stream at the same time. You have just to talk. This is what I understand from IT person.
Ah, okay. So I just
yes.
have to, okay.
This is why...
Just talk? Okay. So, if it is okay, say yes.
Yes, I think we are synced.
Okay. So, sorry for this delay and problem my computer. So my talk will be about our activity on the LISV lab in University of Versailles, and I will focus more on the way we couple assessment and adaptation for mobility assistance. So I will choose some key activity in that field. So sorry for the picture, it's not as younger as you received before. So it is the 2D picture. So this activity is about our University of Versailles. So it is on the southwest of Paris, and mainly known because of the Castle of Versailles. And our university is a part of a big new university named Paris-Saclay. And in Paris-Saclay, you will have, in fact, 18 universities group in the same university. So Versailles is on the west, and we are close to different parts of the university, like autonomous vehicle in Institute of FEDEX, and in our place named Versailles, it's more technological part. And across Paris-Saclay, we have different components of the university, and I choose to present you FEDEX. FEDEX is a federation of lab on human activity, motion, and so on. So you group a number of lab on that field, from hospitals to sport and through activity like us in technology and computer science. So the laboratory LISV has two groups. One is team sensor and nanotechnology, and the second is interactive robotics. I'm in charge of this group, and on this group you have two activities: assistive technology and humanoid. So I will speak the assistive technology part. So the way we develop our research, it's in two steps. The first one is evaluation. So in this activity, we develop a different functional platform. In fact, the idea is to place the user in specific situation, functional situation, and to do analysis, classification, test. So the feedback is for the therapist, and for us is in the developing of the platform with all the tests and the feedback we could have. And for that, we do it with the CEREMH. You will see it's a specific center close to our lab. And in this CRAM cluster, you will find occupational therapists and ergonomists. And on the second step is more the design of the assistive technology. And for example, we do different systems like the arm support or BCI interface. So the CEREMH is an association, and it is now the National Cluster for Mobility Aid, and it is a group of different structures coming from association of users like APF, AFM, with a group coming from the collectivity like LISV, but also Versailles. We have also cluster of industrial cluster and also some components from insurance or big company. And all together, we want to promote mobility for all. That means evaluation and tests to understand the need. We have some particular structure like a mobility school coming from pedestrian to a driving school. And of course, we promote innovation. So we don't do in this cluster innovation, but we assist, like, for example, startup. So some example of project. So here the BCAP. So here we are more looking the driving task. So we have developed this platform. In fact, this platform allows to do tests like the capability to drive a car. So steering wheel and pedals activity could be simulate and could be test. And we could also integrate all the devices you can find on different car, adapted car. So this platform has been tested in different rehabilitation center. And for the driving, we have a specific school with this car, and we have different device to drive, like this example in the movie using a joystick. And we have placed different embedded sensors to evaluate the behavior of the driver, different profile of driver with different kind of disabilities. So the idea is to link the previous platform to evaluate and this car to do really the driving. So it's an example of our way. For the wheelchair driving, we do the same thing, but here we develop different kind of embedded sensor that we place on the wheelchair in order to have some feedback about the behavior of the driver. For example, in this project, we develop a methodology to evaluate by comparison. In fact, we compare the style of driving of a specific user to a data of profile, and by this way, for example, in this project, we give to the therapist different indicator. Here, it was the profile index. So if the user at the beginning changed the profile, after different tests, we could have convergence to a specific profile. So it's an additional index that we develop. We do also assistive specific assistance. For example, in this example, of project named GeroLift. The objective is to develop a two-wheel balance accessible solution. What does it mean? In fact, here you have the idea that we develop is to propose a solution to help the user to sit, but also to stand directly on a specific two-wheel balance system. So we name it geopod. So we have the seats that we place on the different kind of geopod, and based on that, the user could be sit or stand, and then he could move and different kind of mobility. And that is, at the end, inclusive. That means that if it is a valid person or a person with a specific impairment, we could use the same system to develop different kind of mobility. And here you have an example of the system. So it was a PhD. So
Je suis porteur du projet Geralt, qui est le fruit d'une rencontre de personnes
you could see the prototype
et le CRAM qui les a redirigés vers le LISV en fonction des thématiques que l'on aborde. Et le projet porte sur l'adaptation d'un système gyropodique en fauteuil roulant verticalisateur. Je suis Bertrand Nora, docteur de l'Université de Versailles Saint-Quentin. Je fais actuellement un postdoc au sein du laboratoire d'ingénierie des systèmes de Versailles dans l'équipe robotique interactive. Je travaille sur des thématiques d'assistance et d'interaction.
So it was the first prototype. So the question after developing the prototype was the stabilization. So we developed an automatic assistance for that problem. And today we are looking for the stress, because this kind of system could be stress for the user. So we are looking in a new PhD this problematic. And by the way, the GeoLift is now also a startup in the lab, outside the lab. And if you go and Google gerolift.fr, you could have the new design of the GeoLift. And this prototype was presented at Las Vegas, the last one. And Lambert, so the PhD student now, the PhD is in charge of the startup. Second project, in the same way, is virtual fauteuil. That means a platform using virtual reality to help to the designer, the urbanist in terms of accessibility. So it was the first goal of this project, developing with different partners. And as you see in the picture down, it's a robotic platform. On this robotic platform, we could place a wheelchair, and we have the display. So you could move, you could drive your wheelchair. It could be a manual or powered wheelchair, and you could interact with a specific environment that is virtual. So here you have this example of a platform for manual. And some example of experimentation we do. So we want to have the same feedback, and I mean haptic. So here you see the example of the test we did on the platform and on the robotic platform. So we have different applications for that. So coming from a bus adaptation for provider of mobility, RATP in France, in Paris, and different example of tests. And now we are looking for a new application. The idea is to use this platform to help the people who want to learn how to drive a wheelchair using this platform. So here an example of this application.
La réalité virtuelle permet aujourd'hui de se mettre dans la peau d'une personne à mobilité réduite. Virtual Fauteuil a été développé par le CRAM, EDF et le laboratoire LISV de l'Université de Versailles-Saint-Quentin et financé par la région Île-de-France. Il reproduit les principales difficultés de déplacement auxquelles se heurtent chaque jour les personnes en situation de handicap. Le premier objectif de la solution Virtual Fauteuil est d'évaluer l'accessibilité des espaces, habitations ou entreprises, afin de proposer aux urbanistes des aménagements pour favoriser le déplacement de tous. Le deuxième objectif est de sensibiliser le grand public aux problématiques de mobilité pour les personnes en situation de handicap. Le troisième objectif est de favoriser l'apprentissage de la conduite de fauteuil roulant dans les centres de rééducation en sécurité avec des exercices validés.
So today we are looking to different kind of application. For example, we used this platform for the accessibility of different museums in Paris. And we use also this platform with different rehabilitation centers to test, to develop a protocol to help the learning test. So all these projects are linked with different kind of collaboration. So we are going to one project to group every test. The name of the project is Relais des Mobilités. That means a mobility center linked to different living labs. So it's like a network of living labs. So the living lab could be a place to test with different kind of profile, multidisciplinary study, exchange with, of course, the end user, and exchange with different community and university. So as example of this, so the objectives are information, education, and innovation, and to promote that, we have this particular relationship with different centers. So, we start in our lab, but it is an open structure, so we are open to different group, company, and startups. So, for example, the two first community was Vélizy, and the second was Versailles, but now we are grouping different, like Lyon, Paris, and so on. So, we have on the top the lab, then the Fab Lab to do some prototype, the Living Lab to do the test, and the different actor, partner, and the network with different kind of application. For example, the series in Quebec, FEDEX in South Africa, and so on. So the example, in fact, is the GeoLift project. At the beginning, the GeoLift was a demand coming from parents, a family. So he asked for this. So he asked for information, and because there is no information, no kind of solution like GeoLift, we link the research. Then today it is going in startup. The evaluation, the test will be executed on the living lab. So there is some loop in this. So we developed this with one other example with Tohoku University. So it's a system you will see of a wheelchair with pedals. So the objective was to develop for elderly person who has got some problem to work. So you will see the first test wheelchair in the next part of the movie. So using this kind of pedals, here it was passive, but it could be active. So we could add some automatic activation of the actuator coming from the slot, coming from different kind of profiles. So you have different tests we did on the lab. So here was developed firstly in Japan, then test on our living lab with the lab, LISV, and with the occupational therapist. So you see the example. And we did the test on different also rehabilitation center with this system. Another example of the same thing. So we did tests using our prototype, and here it was on the opposite. So at the end, after testing the prototype, the system was developed in Japan, in Tohoku. So we developed the same thing with a French South African Institute. So it is placed in Cape Town and also in Pretoria. So here we have the example of two projects. One was related to virtual fauteuil. It is a simulator. So here the movie from that. So the simulator is bigger, but the idea is the same. We place the wheelchair on a specific robotic platform.
Welcome. You are about to enter a virtual world in an enabled environment. By immersing this world, you will encounter pathways to explore, objects to avoid, objects to enter, and certain real-world experiences. Feel free to explore all. Use this platform to improve wheelchair driving skills, car driving skills, or to evaluate architectural structures. Enjoy the ride.
As you see, we place the person in a specific virtual environment and the user could interact. And we have got all the feedback and information. So in the, the second project, we develop a brain-computer interface. So here, it's an arm support robot system. So we have two interfaces, one coming from the arm detection, and the second coming from the BCI interface. So we mix, we develop an hybrid solution to control, for example, the movement of the arm to grab an object, a glass, in order to drink in this case. So the idea was how to fuse the two interfaces, the brain computer and the arm. So it was another example of the relation between the South African university and our university to do the test. The theoretical part was developed in a co-tutel, in a double diploma PhD, and the test was developed in the CEREMH, in our lab. So today we are going in series relationship, so University Laval. So we have different examples, but maybe you know Mobility, so a specific environment using adaptive mobile geospatial technology. So it was also linked to our project, Assistive, so, and we have specific relationships. And we have the same thing with virtual photo. So normally, in next December, a demonstration will be developed in Montreal around virtual photo. So for that, the Living Lab is an open place to test, to do connection with end user and to have indoor and outdoor situation of test. And of course, to assist the prototyping and to assist startup. And we are going wider, so the idea is to go on all the city of Versailles. So we are looking for a specific serious game. So the idea is to develop monitoring on the city. So based on the geomatic system and based on our connection with the city, we are looking for that. So the idea is to have some feedback on user moving. For example, a user on wheelchair on specific place. Here, the first test will be from the lab to the tramway, so to the train, and from different stations we will have some feedback for the monitoring and for the assistance of driving. So different example of tests with different kind of applications. So, and we are looking also some application for golf. So for example, so for us, it's a sports department. So for example, we have specific tests using gyrolift to do golfing. So because last year it was the date for the Ryder Cup, if you know golf, in Paris, in fact in Versailles, so it was very close to our lab. So we did some demonstration using gyrolift. And we have also a specific project we are starting, mixing art, dance, and handicap. So we are developing some orthesis for dancer. So thank you. So 30 minutes. So of course, all this project was developed with all the team. So I will thank all the colleagues involved in this project, and thank you for listening me, and I hope I could be clear and you understand our activities. Thank you.
Thank you very much, Eric. It was very clear. We still have about 20-30 minutes for questions. Do we have questions in the room? We have many people attending the presentation online and few people in the room, so maybe they could have some questions. Okay, Eric, please stop sharing the screen with us so that we can hear you and you can hear us in a good way. Snow and ice, okay. Oh, I can ask the question, okay. You have the biggest question coming from Winnipeg, Canada. Have you some projects related to the snow and ice and winter mobility, like called by some of the colleagues here? Have you some projects about that? Have you some applications? Have you intention to do some research in that area?
In fact, we are looking to face this problem in connection with the project Virtual Fauteuil, so the simulator. We are looking today the interaction between the skate and the snow, but the idea is to develop this kind of simulator for skiing. That is one answer. And the second is because we have a specific modeling of a city. So, for example, if you know that in a specific place you could face some how do you say that? Some snow, that means some obstacles, some perturbation or some risk. We could integrate this kind of obstacle in our representation of the city. And by the way, the user could train or could have some way to say, okay, in this case, maybe it's not for me. I have to do some shortcut or I don't know. So the idea is today is to integrate some kind of perturbation on the floor. It could be transformed as a specific place with snow. Do you hear me?
Yeah, and how you simulate cold?
We don't simulate cold. We simulate the interaction. Today it is only in simulation, in this step. We simulate based on the representation of specific interaction between snow and the skate today. But we could say that once we develop the interaction, we could have this kind of simulator, virtual fauteuil, transform in virtual skiing, like something like this.
Mm-hmm. I would add some information about that. Maybe I feel like in snow condition in winter cities, snow is not as regular as skiing places or mountain or wherever. Ski is almost more funny than rough snow. So how you could deal with that? Do you need, for example, some data from real life situations or something like that?
Alors, to answer to your question, we are going to develop a specific prototype with snow, and we are looking for different temperatures, so the different phases of the snow. So it is a project that we are going to this month. Mm-hmm. So we are looking for that. So that means a specific profile of the snow, a specific, how do you say that? Phases of the snow, and that change the fitness of the snow, so change the interaction behavior between the ski and the snow, and we are looking for different parameters that we could include, integrate on the model of the interaction. So we are looking for that.
Mm-hmm. Winnipeg is a good place to do some winter mobility ideation and testing if you want to.
So as I said in my presentation, when you look the relais des mobilités, so the idea is to have some connection between different clusters of mobility. For example, you could be one one pole of mobility linked in our network of mobility center. So maybe this example of facing some particular situation of snowing, and you have many particularity in that field. So it could be a way to collaborate.
Indeed. Do we have another question in the room related to that, or maybe another one?
Can you ask them how they integrate their center with the clinical centers?
You have a question from Dr. Gisbrecht.
Can you talk a little bit about how you integrate your work with the hospitals or the clinical people that are working directly with clients?
So we have some relationships. In University of Versailles, you could find an hospital named Garches. So in this hospital, because it is in the same university, we have some connection to do tests. So we have this kind of relation, and around Paris and in different places in Paris, around Lyon. So we have a specific relationship with Rehabilitation Center. So it means memorandum and so on. So in this case, we have we could do tests. Tests could be just a demo with the different prototype with the people, the user in hospital. And some case it could be evaluation or research project directly with the team in hospital. Of course, we have a specific protocol that we first have to develop, like you, I think. And in France, we have ethics committee, and once we develop that, we could do tests.
So can I understand that Hôpital de Garches and other hospital in Paris area are part of Relais de Mobilité?
No, it's directly related to the CRAM or to the lab. Okay. So, for example, maybe it could be an example in BCAP, the platform for evaluation capability of driving. So in this project, BCAP, it is with a Parisian hospital that is focusing the problematic of vision, and in this case, we develop tests in this hospital with CEREMH, the LISV lab, and this specific hospital. We have no connection in the Relais de Mobilité. The Relais de Mobilité, it is more the lab or cluster, not hospital. For today, I mean.
Yeah. So for today, can you please, since we have a little bit more time, can we enumerate the people who are the institutions who are affiliated to Relais de Mobilité network?
Relais de Mobilité today, there is no memorandum, but the people connected to involved in this project, it is CEREMH, so Université Laval and CEREMH, RDPQ and so on. We have in South Africa 2 universities, TUT Pretoria and CPUT in Cape Town, and different associations. Here in South Africa there is no hospital, but only association, user association. In Tohoku, on Japan, there is Tohoku University. So Tohoku is in Sendai, it's on north of Tokyo, and in this place there is one hospital and one rehabilitation center.
Mm-hmm. So the requirement to be affiliated to that network is to be university?
I think for today, because we are developing, the first memorandum will be between CEREMH and UVSQ, University Laval and UVSQ. That will be the first final memorandum. So we are going in the same times for the juridic affiliation, so the model, and to build the Relais de Mobilité. But the idea is to develop something open, but with different group, different cluster, complementary. So, for example, I don't know, you choose a specific focusing, and if it is complementary to the other, that will be a good thing to have this kind of relationship for the relay de mobilité.
Mm-hmm. So in this, in our context in the College of Rehab Sciences, I think that we have a cluster of researchers, some interest on vendor mobility, on tele-rehab, telemonitoring, ambient assisted living, and we have a cluster of private company interested in working with us as well. So could we be part of this network?
I think it will be very nice to be to have this connection, so we have to discuss about that. I think if you have this kind of cluster, we are close to you, so the model and the collaboration, I think, could be a nice things to do. So completely positive for that.
Excellent. And again, since we have a little bit more time, because you were fast today, Eric.
Sorry.
No problem.
Because I have no feedback. You know, when you don't have the feedback, you don't know if you go fast or not.
Yes. No, that was excellent. Maybe if you could both talk about Playa projects and how it is, how we are connecting to each other, and how you are connected in France to the healthcare system, and you have an OT linked to that work. So maybe 5-10 minutes to talk about.
First, let's talk about Playa. So Playa, I don't present Playa because I choose to only the mobility projects. Playa is about computer access. So we develop it for Garches, for hospital Garches. So it was previously a software to like a tool for the therapist to test the user using a joystick, using different kind of interface. So with Playa, it's a free software, it's an open software, so you could develop your own test, or you could use another test coming from a partner, and you have different tasks like using, in fact, you need to test how the patient or the user use the interface, the joystick, the mouse, and different kind of trackball, for example. So it could be pointing, or it could be a drag and drop test, and you have all the feedback, the data, coming from the test. So this software today is developed, you could use, and you have one solution in. So I think, you could develop, you could show the performance of Playa. And
yes,
for that, today, we develop it with two hospitals. One is Saint-Maurice. It's a computer platform. The hospital is on the southeast of Paris. And today, it's new. We just finished a test with orthophonists. So for user with dyspraxy, so the idea is to use this kind of test support, to do this kind of test. So basically, it's always the same thing. You develop your test with your partner. So we could say it's a protocol, and then you could have a test, and all the feedback could be shared between the partner. So it's very easy to upload, to use, and to share the data. The data could be the test, or could be the data coming from the test by the user.
Mm-hmm. Very clear. So that we are working together on this project. We applied to the WCB, Worker Compensation Board. Hopefully, if we get funded, we will work for 2 years to improve this, to finalize this prototype, and put it in 3 languages. If you confirm, Eric, we have a partner.
Yes, because in this, I forget this point. So the first version was developed in French. So we are looking for an English version, an Arabic version, and a Spanish version. So we have one partner in Mexico, one partner in Middle East, and you for the English version. And we are looking also for new kind of application using this software. So because we have all, for example, we have the possibility to to go to tablet version using the same test, the same platform, the same software. I mean.
Excellent. So here in Manitoba, I identified the need with OT, from OT by discussion with OT to use that. So I'm connecting with OT here and the MSOT network as well to develop this. And so once again, as Eric mentioned, this is an open source software. So we both today invite everyone to use it because it's online. You have just to contact the Eric Monacelli team to get it and to use it on any Windows-based computer.
Exactly. And you are connected to all the group of UT that use today this software. So more of them are French, but the idea is to develop the population, the user of that, and to have some specific relationship of user, group of user. That will be like a cluster of player user.
Excellent. Any other questions from the room? Have you any other things to add, Eric?
No.
I know your time is priceless.
No. I hope I could come, I don't know, before the end of the year to explain that directly.
Yeah, we hope to get you to invite you for some times here to work with us. Yeah. In the winter, Archie Cooper told you in the winter you need to test your simulator, but in real life.
Yes, I want to see the winter in your country.
Yeah, -40 and you feel it -50, 60.
No problem. Today for us it's something around 40, so I prefer to have something minus.
Just come to Manitoba then. So thank you very much, Eric, for this presentation, and on the name of the College of Rehab Sciences, we thank you very much for this and for all those explanation and information. Thank you.
Thank you for inviting me, and thank you for listening to me.
That was great. Thank you. Bye-bye.
Thank you. Bye.